Okay, so I asked you to do 1 and 2 off of this sheet. Seems wrong to waste the back side of a sheet. Now I have to confess that one half of the class has different names than the other half. So the first half of the class in question 1 has Logan and Jenna, and the second class is Eric and Fallon, because Logan and Jenna is in the first half and Eric and Fallon are in the second half. But okay, so I'm going to call them student 1 and student 2. Student 1 is the male, student 2 is the female. Okay, whoops, I had already started it and then the internet glitched and it stopped. So let me go back here. So student 1, the male, skates by at a speed. So this is number 1. So student 1, student 2. Okay, so maybe so student 1 is going at a speed. It doesn't say speeding up, so we assume it's a VAV, 3 meters per second. Student 2 is fixing her skates, so her initial velocity is 0. And then after he goes by, she immediately takes after him, accelerating at a rate of 0.8 meters per second squared. Okay, so we don't know, we want to know how long does it take her to catch him. We don't know that. And how far did they both travel? We don't know that. But what we do know is both of them should be the same. Whatever time it takes her to catch him, that's how much time he had to try to skate to keep ahead of her. However far she went, he must have gone the same thing, right? Because here he is as he skates by her. So she's bent over fixing her skate here. Okay? And then she stands up and takes after him. So at some point they're in the same spot, and then sometime later they're in the same spot again. So their delta D's must be equal. So we have 2 unknowns for each of them. So 2 unknowns mean we need 2 equations. We can get one equation from the student 1. Since we have a VAV, and we know VAV is equal to delta D over delta T, we can rearrange and get delta D is equal to VAV times delta T for student 1. For the second one, we have a VI and an A, so we want to do VI delta T plus 1/2 A delta T squared. The VI is 0, so delta D2 is equal to 1/2 A delta T2. Okay, so here are our 2 equations. Our unknowns are delta D, which we said are the same, and delta T, which are the same. So we can, since they're both equal to delta D, and we know D1 equals D2, we can set VAV delta T equal to 1/2 A delta T squared. Okay, now we only have one unknown, it's the delta T. Divide both sides by delta T to get rid of it on this side, and you get rid of the squared here. So now you have VAV equals 1/2 A delta T. Solving for delta T, multiply both sides by 2 and divide by A. So 2 times 3 meters per second, that'll be about 6, divided by 0.08 meters per second squared. And when you do this, you should get a time of 7.5 seconds. Okay, that's the first part of the question. Then it says, how far have they traveled? So now you take the time and fill it in for both of them. So D2 will equal 1/2 0.8 meters per second squared times 7.5 seconds squared. And when you do this, you get a D2 of 22.5 meters. Okay? In theory, D1 should be the same, but you want to make sure it is, so you always check it. If it's the same, it means you did it right. If it's not the same, it means you screwed up somewhere. So 3 meters per second times that's not point, it's 7.5 seconds. I was going to write 0.75. 7.5 seconds. And lo and behold, when you do this, you get 22.5 meters. Okay, which means you can now safely do a happy dance around your room because you got the first one right. Number 2. Number 2, in one class, it's Jack driving his fancy car, and in the other class, it's David driving his car. Okay, so this it's going to be student and teacher. Doesn't say who the teacher is. Okay, so they're driving 64 meters behind their favorite physics teacher. They're both traveling 15 meters per second. So VI for the student is 15 meters per second. VI for the teacher is 15 meters per second. Jack or David get tired of going so slow, so pulls out to pass at an acceleration of 3 meters per second squared. The physics teacher innocently accelerates at a rate, so a 2 is 1.4 meters per second squared. I'm sure she didn't notice they were about to pass. How long does it take Jack to catch up to his teacher? Okay, so if you think Jack or David, so you think here's car of the student, I'll just put an S here, and here's the car of the teacher. And one is the student's 64 meters behind the teacher. So after some time, the teacher's up here. This is delta D of the teacher. And the student does this. This is delta D of the student. So how are they connected? Oh, and that's my other question interfering. So it should be that delta D of the student should equal delta D of the teacher plus 64 meters. Right? So this distance is equal to this distance plus that. So we need an equation for both delta D's. For the student, it'll be VI delta T plus 1/2 A of the student delta T squared. And for the teacher, it'll be VI delta T plus 1/2 A of the teacher delta T squared. What we do know is that the time is the same. Right? However long it takes the student to travel this distance, that's how long the teacher had. So now we're going to sub it in over here. So it's going to be VI delta T plus 1/2 A of the student delta T squared equals VI delta T plus 1/2 A of the teacher delta T squared plus 64 meters. Now this might look horrendously messy, but it's really not going to end up being that bad, because initially they were both going with the same speeds. So there's a VI delta T term on both sides that's going to cancel. Okay? So really you're going to just have 1/2 A of the student delta T squared equals 1/2 A of the teacher delta T squared plus 64 meters. Take both T terms to the same side and maybe multiply by 2 at the same time. So A of the student delta T squared minus A of the teacher delta T squared. And because I multiplied it by 2, the half disappeared. Multiplied it by 2, the half disappeared. I need to multiply this by 2. And now we're going to use that little trick of factoring the T out. So take T squared out. You have in brackets A of the student minus A of the teacher. And now divide. So delta T squared is equal to 128 meters over A of the student minus A of the teacher. So 128 meters over, 3 meters per second squared minus 1.4 meters per second squared. And remember, that's going to be T squared. I think you get 80 here. Second squared, take the square root, and you get 8.944 seconds, okay, for the time. And then the question, it says, how far has each traveled? So now you take that time and you fill it in up here to find out how far the student traveled, and you fill it in here to find out how far the teacher traveled, and they should be different by 64 meters. So when I'm going to run out of time here, but 15 meters per second, 8.944 seconds plus 1/2, 3 meters per second squared times 8.944 seconds squared. And when you do this, you get delta D of the student to be 254.157 meters. Okay? And now you do the same thing for the teacher. The only thing that's different is her acceleration is 1.4. And when you do it for the teacher, you get 190.157 meters